So the next thing we are looking at is we want to know among the three radiations, alpha particles, beta particles, and gamma rays. These are all radiations produced by a radioactive substance. Which one is more penetrating? So in this experiment, we are finding out about the penetration power or the absorption power of nuclear radiations. So we are saying alpha particles, beta particles, and gamma rays from a radioactive source are directed on a human hand, a thin sheet of aluminum should be, okay, there's a thin sheet of paper, there's a human hand first, a thin sheet of paper, then we have aluminum sheet, followed by a lead block as shown below. So we have here our diagram where we want to know which one penetrates most, followed by which one. So we are having here a radioactive source. You see this dark thing here is representing a radioactive source. The source which is producing the alpha particles, the beta particles, and the gamma rays. So they are all here. And as we said, this radioactive source should always be protected. We always protect it with a lead shield or a lead block. So we now direct these three radiations. First of all, we put here a paper. Then the next thing, we put a thin sheet of aluminum. And lastly, we put a thick lead block or lead shield. We want to know which one will penetrate all of them. Now you realize that at this point in region A, they have not yet reached the paper, so they are all present. Alpha particles, beta particles, and gamma rays. Now once they reach where the paper is going to stop to absorb one of them. And that is the alpha particles. So alpha particles are going to be stopped by the paper. So in region B, since alpha particles have already been absorbed by the paper, we shall remain with the two of them, beta particles and gamma rays. Now when they reach in a thin, where there's a thin aluminum sheet, this one also will absorb one. So this one absorbs beta particle. So the beta particles are going to be stopped by the thin aluminum sheet. In other words, they will not penetrate. So in region C, we shall only have one remaining, that is the gamma rays. Now these gamma rays will also go, and ahead of them there is a thick lead shield. Once this lead shield is thick, it means the lead shield can stop them. So they will not penetrate because the lead shield is what? Thick. But if you make this lead shield to be thin, automatically they will pass. So by looking at the three radiations, which one has penetrated more? Of course, gamma rays, which means gamma rays have the highest or the greatest penetration power, followed by beta particles, and then lastly alpha particles. So alpha particles can easily be absorbed by a paper. So this is a simple experiment which can be carried out. So that's why we are saying alpha particles, when you are describing, you say alpha particles, beta particles, and gamma rays from a radioactive source are directed on a human hand, a thin sheet of paper, aluminum sheet, and then a thick lead block. You see, they are all here. Starting with the paper, followed by a thin sheet of aluminum, and that lastly a lead block. So what do you observe? So our observation is according to the regions. We said in region A, they are all there. So under observation, region A, all of them are there. Alpha particles are present, beta particles are present, and gamma rays are all there. Then when you go to region B, we said alpha particles were already stopped by the paper, so we remain with the two. We shall remain with the beta particles and gamma rays only present. Then in region C, we shall only remain with one, that is the gamma rays only. So we can conclude by saying gamma rays have the highest penetrating power, or you can say the greatest penetrating power, followed by which one? Followed by beta particles, while alpha particles have the lowest penetrating power, or the least penetrating power. Now we want to remind you that alpha particles can also be stopped by, apart from, it can be stopped by a human hand. So if we had put the human hand before even the paper, automatically the human hand could stop, while beta particles and gamma rays are not. So when you put a paper, you realize that a paper can stop alpha particles, but cannot stop beta particles and gamma rays. In the same way, if you put a human hand can stop alpha particles. So alpha particles can easily be stopped by a human hand. So we can now look at radioactive decay. A process, radioactive decay simply means a process by which an element changes into another element by producing or by emitting nuclear radiations, from the nucleus. So a process where an element changes into another one, and for it to change to another one, it changes by producing radiations. What are these radiations? Alpha particles, beta particles, and gamma rays. It is very true that some elements can change into others by producing all those rays I've mentioned, but others, they change into new elements by producing only alpha particles. Then others can change into new elements by producing only beta particles. Others by producing only gamma rays. But there are those which produce all of them. So a process where an element changes into another element by emitting nuclear radiations from the nucleus is called radioactive decay. There are three types of the radioactive decay. One is called alpha decay. That is when alpha particle is produced. You see, an element changes into another one, and then it also produces alpha particle only. That is alpha decay. Then when a beta particle only is produced, that is beta decay. When gamma particles are produced only, we call them gamma decay. So there are three types of radioactive decay. Let's look at them one by one. Let's begin with alpha decay. Now when we say alpha decay, it means an element changes into another one by producing alpha particle only. So alpha particle is one of the products. So we are saying when a parent nuclide, you see, when a parent nuclide X, so a parent always produces a daughter, not a son. In radioactivity, a parent produces what? A daughter. So when a parent nuclide, so the parent is called X, decays, when a parent nuclide decays by alpha emission, when a parent produces an alpha particle, the atomic number of the daughter nuclide, and we need also to give the daughter nuclide what? A name. Here we are calling it what? Y. The atomic number of the daughter nuclide Y decreases by 2, and the mass number decreases by 4. You see? So during the alpha decay, when an alpha particle is produced only, remember we are saying radioactive decay is a process where an element changes into another one. So the parent produces the daughter. But in the process of producing the daughter, alpha particle is also produced. So there are two things produced. There is a daughter being produced, there is alpha particle being produced. But also, it gives out energy. Most of these radioactive decays, they produce what? Energy. So let us see an example or an equation. Supposing this is the parent. Of course, the parent has atomic number and mass number. Sometime back when we were talking about atomic number, we said atomic number, generally we use the letter Z. Mass number, we use what? A. So the parent is X. Then it produces, you see, this parent is alone here, but is producing all this. One of them is what? Energy. You see, energy is also given out. All these radioactive decays, whether it is alpha decay, beta decay, or gamma decay, energy is what? Given out. Although sometimes we don't write it in the equation. Then this is an alpha particle. Remember, sometime back we said alpha particle is a helium atom with atomic number 2, mass number 4. So this is an alpha particle produced with what? Energy. And then the daughter is Y. So if we are to balance the equation, what happens? We said the mass number, the atomic number, what did we say here? That it decreases by 2, that is atomic number. And then the mass number decreases by 4. So if this is the daughter Y, you know, we are saying atomic number, we use the letter Z. To decrease is to reduce, so minus 2. The atomic number for the parent is Z, so for the daughter decreases by 2, Z minus 2. So if this is 90, this one becomes 90 minus 2, which is 88. Then the mass number was A for the parent. Then for the daughter, we said the mass number decreases by 4, A minus 4. So if this was 230, this will be 230 minus 4. So as we said, this one represents the parent, this one is a daughter, and then this is an alpha particle, plus of course energy. So that is a general equation. We can have an example here where we have the parent is Ra, that is radium, that is a symbol in the periodic table, that is radium. Radium has atomic number 88, mass number 266. So if that is the parent, then it produces the daughter. You see, this was now the parent, we call the X. Now this is radium. Then it produces radon. You see, that is the daughter. Now I want you to compare the atomic number. The atomic number here is 88. So this one, what happens? What did we say? Atomic number reduces by 2. So it becomes 88 minus 2, which is 86. Then look at the mass number. The mass number of the parent is 226. So what did we say? When an alpha particle is produced during alpha decay, the daughter will have atomic number of the parent minus 4. So we subtract 226 minus 4, you get 222. Plus alpha particle is produced plus energy, although we have not written there. Sometimes we ignore, but it's also good to know that energy is produced. So this is an example of alpha decay, where parent, this is an element, this is also an element. This is a different one. This is a process. We are saying radioactive decay is a process where an element changes into another one. You see, this is radium, is different from Rn. Rn is a symbol for radon. So a process where an element, a parent, changes into another element by producing a radiation. In this case, the radiation produces an alpha particle. Because it is only alpha particle produced, we call that alpha decay. Now let's look at some questions which can be set related to what I have just said. Sample questions. Let's look at question number 1. It says uranium, and I've written uranium. Uranium 238. So the mass number is 38. The atomic number is 92. And this is U. U is a chemical symbol representing uranium. So they have given us the parent, how the parent looks like. It is called uranium, and the symbol is U. It has atomic number 92, mass number 238. And we are told it decays by alpha emission. Sometime back we said you can write alpha particle in full, like this. Now the symbol for an alpha particle is this. But you could also write this, you just write this, you put a dash and put particle. So this, we read this as alpha emission. When we say alpha emission, it means an alpha particle is produced like this one. You see in this equation, there's an alpha particle. So this is alpha emission. So this is the parent, it decays by producing an alpha particle, alpha emission. And this person wants us to write down a balanced equation for the decay, 1 mark. Then secondly, he wants us to name the daughter. What is the daughter nuclide? After giving us the parent as this one. So when this parent produces, an alpha particle, by emitting up alpha particle, it means it changes into another element, the daughter. So they want us to write the equation. So what did we say? Whenever it is alpha emission, the atomic number decreases by 2. So the daughter will have 92 minus 2, which will be 90. Then this will be the atomic number. Then the atomic mass will also decrease by 4. So while the parent is 238, the daughter will be 238 minus 4, which will be 234. So we write the balance equation, starting with the parent. This is how we're given how the parent looks like, but we're not told the daughter. And the parent must produce a daughter, an element changing into another one. So since we don't know, we can use any letter. You can use even X, you can use even Y. So we have used here Y. So plus alpha particle. Why are we saying plus alpha particle? Because of this word, alpha emission. If it was a beta emission, it means we would have beta particle. If it is a gamma emission, we would write a gamma particle, or gamma rays rather. So our equation is going to be the parent giving us the daughter. We can use any letter Y because we don't know, plus alpha particle. Then you balance. You see, when you add this 4 plus 234, you get 238. You balance the mass numbers. Then when you add 2 plus 90, you also get what? 92. So after writing the parent equals to, you put an arrow, then the daughter you don't know, you can use even any letter, even W, plus alpha particle. Then you ask yourself, what should I add to 4 here to give me 238? You see? And then what should I add to 2 here to give me 92? Automatically this is 90. But we already said the daughter's atomic number reduces by what? 2. So you just simply get 92 minus 2, you get 90. Then the mass number reduces by 4. So you just subtract 238 minus 4, you get 238 minus 4, you get 234. So this is the balanced equation. You see, the top part is balancing, this plus this equals this. Even the downer part is balancing. So this is the balanced equation which the examiner wanted. Now let us look at the second question. The second question demands the name. What is the daughter nuclide? So they want us to name the daughter. This is the parent, this is the daughter. So we are supposed to name this daughter. So how do we name the daughter? We are going to use the periodic table. You see, the periodic table has very many elements. Normally in chemistry, from senior 1 to senior 4, especially in the Ugandan syllabus, they always give the first 20 elements. But of course, we know there are more than 20 elements. You see? So there is an element which has atomic number 90. We said whatever is down here is atomic number, and whatever is up is what? The mass number. So if you want to know the name of the element, you don't use the mass number, you use the atomic number. So for us, we shall say, if you cross-check very well in the periodic table, we are quoting that from the periodic table, the element which has, or with atomic number, the one which has atomic number 90 is called what? Thorium. You see? So this is supposed to be thorium, although we are calling it Y. But the name is thorium. Why? Because you look at the atomic number. So you are supposed to study most of those elements in there. So you are supposed to go beyond the first 20 elements. You should know as many names of the elements in the periodic table as possible. So the one with atomic number 90 is called thorium. So if it is a thorium, which symbol do you use for writing thorium? You just write TH. So instead of Y here, you write T and then H. But you can still leave it. 23490 Y, which is actually this daughter is called thorium. So we have answered that question properly, and you get all your